Hi everyone, I am Preeta Raman from ADS department. Today I am going to present a topic from neural networks, which is multi-layer perceptron MLP or non-linearly separable data. This topic explains how neural networks are capable of solving complex problems that cannot be solved by simple models. Let's see the introduction of neural networks. Artificial neural network or computational models inspired by biological neural networks of the human brain consist of interconnected processing elements called neurons able to learn from data and improve performance, used for tasks such as classification, prediction, pattern recognition, and decision making. The simplest form is the perceptron, proposed by Frank Rosenblatt in 1958. It can only solve problems. Introduction of multi-layer perceptron. In multi-layer perceptron, the network is organized into multiple layers, namely the input layer, one or more hidden layers, and the output layer. The input layer receives the raw data in form of features. This data is then passed to the hidden layers where most of the computation takes place. Each neuron in the hidden layer processes the input by multiplying it with bytes, adding a bias, and then applying an activation function. Finally, the processed information reaches the output layer, which produces the final prediction or classification result. One of the most important features of MLP is the use of activation functions. These functions introduce non-linearly into the network, allowing it to learn complex patterns in the data. Non-linear separable data. Non-linear separable data refers to data sets in which the classes cannot be separated using straight line in two dimensions or a flat plane in higher dimension. Instead, these data sets require curved or complex decision boundaries to distinguish between different classes. This type of data is very common in real-world applications where patterns are rarely simple or linear. A well-known example of non-linear separable data is the XOR problem, where the output is 1 when the inputs are different and 0 when they are same. When plotted graphically, the data points are arranged in such a way that no single straight line can separate the two classes correctly. This limitation highlights the weakness of single-layer perceptron, which can only create linear decision boundaries no matter how much training is applied. It can correctly classify one-linear patterns like XOR. Structure of multi-layer perceptron. A multi-layer perceptron consists of three main types of layers: the input layer, hidden layer, and the output layer. The input layer is the first layer of network, and its main function is to receive the input data in the form of features. Each neuron in the input layer represents one feature of the dataset, and it simply passes the data to the next layer without performing any computation. Hidden layers are the most important part of MLP. These layers perform immediate computation and are responsible for learning complex patterns in the data. Each neuron in a hidden layer receives inputs from the previous layer, multiplies them with corresponding weights, adds a bias value, and then supplies a activation function. Activation function in MLP. Activation function plays a very important role in multi-layer perceptron because they introduce non-linearity into the network without activation function. Even if we use multiple layers, the entire neural network would behave like a simple linear model that would be able to solve complex problems. Therefore, activation functions are essential for enabling the network to learn and represent non-linear relationship in data. In hidden layers, one of the most commonly used activation function is the rectified linear unit. It is defined as output equals 0 for negative inputs and equal to the input for positive values. Decision boundary in MLP. One of the most important features of multi-layer perceptron is its ability to create non-linear decision boundaries, which makes it more powerful than a single layer perceptron. A decision boundary is a line, curve, or surface that separates different classes in dataset. In simple models like a single layer perceptron, this boundary is always a straight line or linear plane. Because of this limitation, such models cannot correctly classify complex datasets. In contrast, an MLP can generate curved and highly flexible decision boundary. This is achieved by combination or multiple hidden layers or nonlinear activation function. Each hidden layer transforms the input data set by step into a new loss function and optimizer choices. In a multi-layer perceptron, choosing the right loss function and optimizer is very important for achieving good performance. The loss function is used to measure how far the predicted output is from the actual target value. It acts as a guide for the model to understand how well it is performing and how much improvement is needed. The selection of the loss function depends on the type of problem. For classification problem, especially binary or multiple classification, cross-empty loss is commonly used because it measures the difference between predicted probabilities and actual class labels effectively. Next, regularization and augmentation. In a multi-layer perceptron, one common challenge is overfitting, where the model performs very well on training data but poorly on new unseen data. To overcome this issue, to improve the model's generalization ability, techniques such as regularization and data augmentation are used. Regularization is a method used to reduce the complexity of a model and prevent it from memorizing the training data. One commonly used technique is L2 regularization, also known as weight decay. In this method, a penalty term is added to the loss function based on the magnitude of the weight. This encourages the model to keep the weight small, resulting in a simpler and more stable model that generalizes better. Another effective technique is dropout. Validation and performance metrics. In a multi-layer perceptron, evaluating the model's performance is an important step to ensure that it works well only on training data but also on unseen data. For this purpose, the dataset is usually divided into different parts, such as training and validation sets. A held out validation set is used to test the model during training without affecting the learning process. This helps in estimating how well the model will perform in real world scenarios. Another reliable technique is cross validation, where the dataset is divided into multiple datasets and a model is trained and tested multiple times using different combination of this subset. This approach provides a more accurate and stable estimate of the model's performance. Conclusions. In conclusion, the multi-layer perceptron is a powerful extension of the simple perceptron that overcomes its limitations by using hidden layers and non-linear activation functions. It plays a crucial role in solving non-linearly separable problems and has become an essential tool in modern artificial intelligence and machine learning.